Gentlemen, ladies, everybody, welcome. This is an information video of the Celeritech true equal length headers for the BMW S85 engine that will fit all BMW V10 cars as the E60, E61, M5 and the E63 and E64 M6. This header project is a cooperation between Celeritech, Europower Motorsport and Party Racing. We start with a small introduction of us, Celeritech. Here you can check our website. There's tons of information about our service. You can check our portfolio. We are pretty known. There's also stuff on YouTube, the BMW V10 for the one that didn't know. You can also check here us in the media, our partners, etc., etc. And we also have Party Racing here. You can see the owner of Party Racing. There's tons of knowledge about the BMW engines, mostly the M models. And then here we have the Europower Motorsports web shop. So where do we start? We could start with the flanges. Sound maybe logic, but we start with equal length, or to be exact, true equal length. You probably heard about it before, and many other of the competition claim it's equal length, but I dare to challenge them and prove it because, well, everything we measured, it was not even remotely close to equal length. It is practically pretty complicated to even achieve that. Celeritech, we developed our own software in-house, our machines, our tools, our whole method to not only design it true equal length, but also fabricate it like true equal length. I will show you a little bit later about software, but let's first start about why equal length. And with true, we mean that it is really equal length. That could be a really long video. I'm not going into that much because there are pretty okay videos about that. In practice, it's the best for performance because then all cylinders will run the same. The exhaust is an important part of the engine. Many phenomena are playing a role in that. One of the most important are the finite amplitude waves. They travel through the tube, and when they see a transition, like in the collector, they return in the opposite amplitude. And if it starts as a positive wave, when exhaust valve opens, then it travels through the tube. It sees a transition from small to big, and then it returns in the opposite amplitude, so as a negative pressure. And you want that to arrive at the right time, which is just before exhaust valve closes. Okay, the videos go deeper into that, but you can imagine if all cylinders run the same, it's the best. They all run optimal and they all run equal, so there's even less vibration, etc., etc. And most of the time, the intakes do have equal length. So the exhaust absolutely not, but if you have it, it is best for performance. Not only that, it's also best for sound. It's like a tuned piano. I mean, all pulses come perfectly after each other. So yeah, if you're not even, if you're off like 10 centimeter, that's almost the best we ever measured of the competition, then still not only the pulse but also the flow of the gases, they add up here because they can then arrive partly simultaneously. Well, must be honest, with a 5-cylinder you always have it partly. The best would be a 3-cylinder, but at least it's perfectly after each other. And it's minimal that it all adds up, and then you get choking right after the collector. So it's for power, it's for sound. Here I will show you shortly how we work. We always start with, well, the CAD files if they are available. That is really ideal. Sometimes we do photogrammetry. The result is absolutely stunning, as you can see. But I would say at least 9 out of 10 times we will use a scan, which you can see here. We split it up in several parts. We can make it transparent, and this is our working space. Here we start with our program. We start, of course, with the flanges, and we work from there. And yeah, we use everywhere where there is space, we use it. And I have to say, this was one of the most difficult ones ever. The space is really tight, and you do want true equal length. And I have to say, you also want a certain length. Let's say for a street car, if it is not really high level racing, then 75 centimeters. So let's say about 30 inches. That's a really nice length, but that makes it extremely difficult to get it all fit, 5 pipes, into the very tight space. So we start, for example, with, well, let's do it like this. So here it's, yeah, pretty good to see the starting point. You see the extremely tight space already. Maybe in case you think, hey, there is space over there, why didn't you use it? Well, it's not. Here you can see the rack and pinion, the steering. Here's the steering column. Heat protection everywhere, the engine mount, and well, yeah, good luck with designing. But yeah, took a long time, but this is one of the most, yeah, difficult challenges we ever did. And well, if you look on our website, in case you didn't do it already, I mean, okay, the V10 was a bigger challenge, but for the rest, we're pretty well known for our complicated design, and this is one of the best ever, I have to say. So as I told you, all true equal length. What more can I tell you? Well, I can show you a little bit in the transparent version, maybe some more details, how nicely this is designed. It's always a little bit difficult to see in the transparent version. If you switch over, for example, you can see some details, but you can't see everything. The other side, that was really the most tight space. If I remove that one, you can see everywhere how nicely this is designed. Here you see some heat protection touching it, but that is just to reach this bolt. There is more than enough space. By the way, it's same on the other side. So yeah, really, really, really nice. So let's talk about the exhaust itself. Now we start with the flanges, and that is already something pretty interesting. These will be CNC'd, they will be machined from billet stainless. The whole headers, by the way, will be in stainless 304. That is the choice for headers. You have also 316, but that's more for marine applications because it can resist salt water. You have 321, which is for turbo applications. It's more resistance to really high temperatures, but it's pretty much more expensive. You could use Inconel, mild steel, etc. But normally the choice is stainless 304. So the flanges will be from stainless 304 machined, and what you have to do, you have to go here. We look at the scan of the engine, and we can look a little bit inside the port. It's of course dual valve, so it ends up in an oval. And here you want a really nice transition from the shape of the port to the round shape of the tube. So you have to make a transition All of the competition doesn't do that. They do maybe the oval shape, but then they kind of, yeah, there's always, look at how it flows, there will always be resistance, some obstacle, whatever, and we decided to do really nice CNC machined flanges. So you go from oval to round. It needs a certain length, not much that you have, because you're very limited in space. So you start immediately with the bend. And we started with 42 millimeter, which is slightly bigger than stock, but it also matches pretty much nicely the port and cross-sectional surface area. We also need that because the minimal bend radius that you can get is smaller on a smaller diameter tube. So I really wanted to go to the next step, which is 45 millimeters, which you can see here. But the first part we also wanted, but we also needed the 42 to make the shape possible, the form. So what we did is at almost 1/3 of the total length, we made the transition. Everywhere it is at the same spot, and then it goes into 45 millimeters. So yeah, first 42, then 45, and everywhere you will see at 1/3 of the length a transition. Both sides, of course, the transition, which makes the design really more complicated. But if you really want to free up the flow without resistance, and if you do already true equal length headers and a good axle systems, and you have a good running engine, you really need some more diameter to get it through all the lengths. If it is a shorter header, which is not the right length, so you will lose power, but then you can go a little bit smaller. But the longer it is, the more it will cool down, the more it will, by that, slow down, and you want to keep enough cross-sectional surface to get it all flowing. What more can I tell you? Well, of course, it all comes together in a 5-into-1 collector. That is the best configuration for a V10, double 5-into-1. What we always do is slip-on collectors. Why not weld this? Well, there are many reasons, also fabrication-wise, but if you do slip-on, you keep a little bit of total play, so you can really position the headers the way you want. If you weld everything, then it is one stiff part, which is probably also impossible, or at least very hard to mount. Now at least you can detach some parts, maybe even we have to test that all parts separately. It looks like a puzzle, but the puzzle very likely can be solved. And then you can mount it pretty easily. It's, of course, if you make a stock header design for, all of the cars, then you take into account that it is also easy to mount. This will be harder to mount, but eventually if you do them all by one, then you constantly can keep some space for the bolt so you can reach them. Again, it will be a puzzle, but the puzzle will be solved. You can only do that if you don't weld it together. And again, it gives some play. You can push, pull, and actually turn the collector slightly and wiggle everything so it fits really nicely. That always helps with positioning everything. You would say, well, wouldn't be every header exactly the same if you have that high standards? Well, yes, the header is, but the car probably isn't. There are always tolerances in manufacturing. Actually pretty a lot. In the old days it was worse than now, but it's still there, and it can actually vary a lot. But not only that, you can have new engine mounts, you can have old engine mounts, the car can have had damage maybe. So it's good to have some play that you just can position it the way you want it. So that's why, plus, yeah, it looks ultimate if you ask me. Nice spring retainers, that's the C from Celeritech, obviously. Here our logo, that it is proof that it is true equal length. Then we come to this V-bend clamp. Why here a V-bend clamp? Well, the reason is that in the future we will design the rest of the exhaust system. This one will fit the stock exhaust. Maybe we can design something if somebody already has a certain exhaust that doesn't fit stock. We could make it, then you don't have to buy everything. You can keep the collector, which is pretty inexpensive part, and then we only have to fabricate this part. And the moment we will design our own exhaust, then probably we will go a little bit wider, though we will keep this because it's actually very good to keep it pretty tight right after the collector to speed up all the mass flow. So you create a bigger vacuum here, so they will suck on all other tubes when you have constantly a flow of one pipe, of course, when the exhaust valve is opened. This is the original flange. It will fit the stock exhaust and two lambda sensors as you need. So yeah, I think that sums it up for these headers. This is absolutely not only the most beautiful design, it will perform absolutely the best out there. It will absolutely smash the competition, not only in performance, but also in sound. In the future we will have dyno results. This is the video for the pre-order. But yeah, we have so big of a variety of results from the past for all our headers, and always it's absolutely best out there. Of course, it is true equal length. It is always the right length, the diameter, attention to every detail. And we do originate from high-level racing. We have done a lot of engine simulation and development. These headers will absolutely be the best out there. So far, that's it. I would say thank you for watching, and if you do have any questions, be free to contact us. Thanks.